Hello everyone. I would like to continue with previous video. In previous video, we are given 6 points and we need to prove whether or not these coordinates are the solution for this equations right here. Negative 3x plus 5y equal to negative 18. And what we did, we substitute this value into this equation to make sure that the left-hand side equal to the right-hand side. So if it's equal to negative 18, then it means that the statement is true. Okay, so we substitute the value of x and y into the equation, and we find whether or not it's true or not true. So we found 2 points that are not true. So what we are going to do is I list them for everyone to see, and I can tell you that if I plot these 3 points on the Cartesian plane, and if I connect them, they will form a straight line. And the negative 6 and 0, 1 and 3, they will not stay on the graph. Okay, so let's do that. So plot this point on this Cartesian plane. Okay, so I have some graph paper here, and I would like to show everyone how I sketch the y and the x-axis. Okay, so what I will do is I will sketch the y and the x-axis, and then I divide up the scale. So I need to demonstrate this for everyone in case that you need to plot the x and y axis on the graph that provided for you. Okay, so here is my y-axis and here is my x-axis. Okay, so I make sure that the arrows stay on this side to present that this is the positive and this is the positive for y. Okay, so I'm going to label that. So this is x and this is y. And I need to divide up the scale. Okay, so I need to assign the number for all of this increment. Okay, so what I will do is I will make this as 1. So that means that has to be 2, that has to be 3. And this will be 1, 2, 3, 4, 5, 6. Okay, this will be negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. The same thing here, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. So let's label that. So this will be 1, 2, 3, 4, 5, 6. 1, 2, 3. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So this would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Alright, so let's find the point that we have to plot. So first of all, the point is 6 and 0. Okay, so 6 and 0 is this point right here, 6 and 0. So that is the point. Alright, okay, then what I'm going to do next is I will have the next point I have to find is 1 and negative 3. So 1 and negative 3 will be 1 and negative 3. Alright, so let me go down to find 1 and negative 3 is down here. So it is this point. Alright, okay, so this is 1 and negative 3. So I want to label that before I forget. So it's 6 and 0. And this is 1 and negative 3. Okay, so the last point I have to find is negative 4 and negative 6. So right here, going down from negative 4, I meet the negative 6, so it should be this one. Alright, so this one is negative 4 and negative 6. Okay, so what I'm going to do next is I will write, I will plot a straight line, and I can prove to you that it will go through these 3 points. So in a way that these 3 points will create a straight line. Okay, so let me draw that straight line. And I connect the graph. Okay, I connect the graph like this. Connect it to show that it go through this. So you see, to be quite precise, it's actually go through this 3 point here. So this is the 6 and the 0. This is the 1 and the negative 3, and this is the 4 and the negative 6. So this line representing negative 3x plus 5y is equal to negative 18. Okay, so you see a straight line, you can connect any 2 points to make a straight line. But to make it go through this point, we'll prove that they stay on this graph. And these 3's are solutions for this graph. So let's check the other 2 points. So the other one is negative 6 and 0, so let's find that. So the negative 6, I will do this in purple, okay? So the negative 6 and 0, that means I have to go here and check this guy. Negative 6 and 0. So negative 6 and 0, it stays way off. It doesn't stay on this straight line at all. And this one is 1 and 3. So when I do 1 and 3, I am going to find this 1 and 3 is this one, which is not on the graph at all. So 1 and 3. So it takes 3 points to prove that is they form a straight line. Because you can connect this 2 anytime you like, right? So you can connect this 2 point, but does that represent this equation? No. Okay, so this 2 point definitely represent the solution for this linear equation. But to prove that, you see that you must have another point to prove. My point here is this. Okay, you need 3 points to form a straight line. Is that correct saying? Actually, if you argue with that, you can see that, oh, it takes 2 points to connect to make a straight line. But whether or not that straight line is true to this statement, is true to this equation, that means you need 3 points. Okay, so 2 to connect, but 1 to prove. So the reason I emphasize this is because on our next example, you have to sketch a linear equation. Okay, so let's take a look at our next example right here. This next example telling us to graph a linear equation using x and y intercept and 1 test point. You see, x and y intercept and 1 test point is actually very important. Okay, so what are x and y intercept? X and y intercept are the coordinates where the graph intersects the x and y axis. So x-intercept will have the value for x, but it will be 0 for y. Y-intercept will be the 0 for x, but there is a value for y. Okay, so here are the steps. A step for graphing linear equation using x and y intercept and 1 test point. That means you determine the x-intercept by substituting y equal to 0 into the linear equation, and then you solve for x. Okay, so that's step number 1 to find the x-intercept. So step number 2 is determine the y-intercept by substituting x equal to 0 into the equation and solve for y. Okay, so you connect the 2 points to form the straight line. But you must choose any other values for x except for 0, because it's already have the 0 here, right? So which is easy to calculate. Then substitute this value into the linear equation to solve for y. Check to make sure this point stay on the graph. You see? So to make sure this point stay on the graph in a way that you need to have 3 points to make a straight line. 2 points are not enough, but the 3rd point is the one that proven that you have done it correctly. Okay, so let's take a look at this graph of the linear equation. 5x plus 4y minus 20 equal to 0. I need to graph this linear equation using the x and y intercept and 1 test point. So the step number 1 is I rearrange the equation like this. negative 5x plus 4y equal to 20, because I want to make sure that I am going to solve for x, but let y equal to 0, and solve for y, but let x equal to 0. And then what I do is I rearrange the equation so I can have all the variables on one side and the number on the other side. Okay, so first of all, we are going to find the x-intercept. Okay, so x-intercept. So what does that mean by x-intercept? I have to let y equal to 0. So that means I'm going to substitute y equal to 0 into this equation. So I'm going to label this equation as the equation star. Okay, to solve for x. So then I will have minus 5x here plus 4 times 0 equal to 20. Okay, 4 times 0 is 0, so I have negative 5x equal to 20. I divide this by negative 5 on both sides. So therefore, I will have x equal to negative 4. Alright, okay, so you should pull out a pair for this as well. So this pair will be negative 4 and 0. Okay, when you let y equal to 0, you found this. So this is the x-intercept. 1 point on to plot the graph already. The next step is to find the y-intercept. So what does it mean by y-intercept? I will let x equal to 0. So let me double check up here. I said let y equal to 0. Now let x equal to 0. That means I'm going to substitute x equal to 0 into equation start to solve for y. Okay, so that means negative 5 times 0 plus 4y will be equal to 20. Okay, so that means this equal to 0, so 4y equal to 20. I divide both sides by 4. So I should have y equal to 5. So that means you cancel out that. So now you should write the pair out as well. So when x equal to 0, y equal to 5. So this is your next one. Okay, so we double check that. We are good. We double check that. We are good. We have 2 points already to plot this graph. But it's not enough. You need another point to test. Okay, so I'm going to do that now before I plot them. So the very first thing I do is I will choose any value for x. Okay, so let's rewrite our equation. Negative 5x plus 4y equal to 20. So excuse me for a minute. I need to drink a sip of water. Thank you. It's just my voice is getting dry. So I'm going to choose a value so that I can solve for y. Okay, so I'm going to choose a value for x. And I substitute into the equation to solve for y. And I'm going to choose the one that's easy to find the y. Okay, so let's say I choose x equal to negative 2. Okay, you can choose whatever value you like, except for 0. So I can tell you that if you choose 1 right here, then what you have, you end up with negative 5. And for y equal to 20, you move this over, you end up with a number. But when you divide it, it may not turn out to be an even or maybe a nice values for y for you to plot. Okay, so in this case, I am going to choose x equal to negative 2. Okay, then substitute x equal to negative 2 into star again. So this equation, I call it a star. Okay, so here I will have negative 5 times negative 2 plus 4y is equal to 20. So this should be positive 10 plus 4y equal to 20. You will add 10 to the side. Okay, so here is 20 and plus 10 plus 4y. So I am going to subtract 10. Okay, subtract 10. Okay, so if I minus 10 on both sides, I will get rid of this. Okay, so this will be gone. I will have 4y equal to 10. I divide both sides by 4. Then I should have y equal to 2.5. Okay, fairly easy point to sketch. So that means my point could be -2 and 2.5. So that is my third point. Okay, so you have to try. If you pick 3 and you pick 1, so what values do you get for the y? If you end up with like an irrational number, then it's hard for you to find that point on the graph. And then this one is a decimal where I have 2.5, so which is the point that fairly accurate for me to find on the graph. Okay, so let's take a look at our graph paper, and we are going to plot. All right. Okay. So what I am going to do is I will show everyone how to plot this as well. So I will go up from here to get my y-axis. Okay. Then what I'm going to do is I'm going from here to plot my x-axis. Okay. Now I'm going to choose the scale. So the scale I'm going to get is 1, 2, okay, so this is -1, -2, -3, -4, -5, -6. And here I should have 1, 2, 3, 4, 5. There should be 6. I will have 1, 2, and here should be my 3, right? Okay, but I don't need to really worry about this. Okay, the reason is I kind of planned ahead for the 3 points that I'm going to find on the graph. Okay, so let's label this. So this is 1, 2, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, -6. So the first point is the x-intercept, which is what we found up here, is -4 and 0. Okay, so -4 and 0. And this is -4 and 0, so that plotted in red. So this should be -4 and 0, which is this point right here. Okay, so I will make -4 and 0. Okay, so the next one is 0 and 5. So right here is 0 and 5. So I will write 0 and 5. And the test point that I found is -2, right? And then we're going up to get the 2.5. So you see, I choose a scale so that right in between 2 and 3, I can easily find 2.5. So right there is -2 and 2.5. Okay, so let's connect these 3 to see if they lie on a straight line. Okay, so right here I'm going to connect it like this, and you see that they form a complete straight line pass through this 3 points right there. Okay, so if I can click this in to make sure that this point, and this point, they all stay on the graph, and this graph is actually -5x plus 4y minus 20 equal to 0. So that's why you really need to find 3 points in order to sketch the graph. Okay, so let me move down to show everyone what happened. Okay, right here is the one that I use the software to plot the graph for you. Okay, so this is my -4 and 0. So this one is let's see, I have 0 and 5, which is up here. Okay, and the point that we have is -2, and here is 2.5. See that? So this is my -4 and 0. Okay, so let me write this again to make sure that I write it correct. So this is -4, 0. So this is -2 and 2.5, and this point right here should be 0 and 5. And this line is also -5x plus 4y subtract 20 equal to 0. Okay. Alright, so let's check another point. Okay, so let's check another point. If you want to go further and checking another point, you can go like this as well. Okay, so you can pick a point on the graph. So right here, you can pick this 10 for y and 4 for x, and see whether or not they actually stay true to this equation. So I'm picking 4 and right there, because I see is going through this point, right? So I will put 4 and 10, and then I will check. Okay, so I will have -5 times 4 plus 4 times 10. Let's say it's equal to 20. Okay, so this one is -20 plus 40 equal to 20. Yet it is, so 20 equal to 20, so it's true. Okay, so you can continue to pick a point that you think that stay on the graph, and then you can check. But you need just you need 3 points to form a straight line. Okay, you can argue with me that, oh, I only need 2 points on the graph in order to sketch the graph. However, those 2 points may not be correct. The third point is the one that you are going to test to see that your x and your y intercepts are actually the correct values. Okay, so therefore, each time that you sketch a graph, you will have to find 3 points at least to sketch the graph. Alright, let me see what I have next. Oh, next is I just assigned the exercise for everyone to work on. It's very much similar to what I have done, similar to the example. Okay, so I also asked everyone to graph the linear equation using the x and y intercept and one test point, and also ask everyone to plot the points on the Cartesian plane, connect those points to see if they actually form a straight line and which points are actually not on the graph. Okay, so I hope I covered everything and say everything I needed to say. And basically, I want to emphasize the fact that when you are dealing with a linear equation, and if you have to sketch that, you need 3 points, x and y intercept, so you understand the definition of what x-intercept is. So if x-intercept, y has to be equal to 0, y-intercept, then x has to be equal to 0. Okay, so the magical thing about the linear equation is that if you have a set of points, x and y, if they stay true to your equation, that means they are the solution for this equation. That means they are the point on your graphs. Okay, so I believe that I cover everything for everyone. Linear equation, the definition for that, plot the point to see if they are on the graph, and we can prove to see that they stay true to their statement. If they are not equal to each other, that means those points are not on the graph. And from that idea, we are plotting the graph, the linear function or linear equations using the x and y intercept and one test point. Alright, okay, so I am going to stop the video right here. So why I'm plotting this, I hope that I show everyone how to kind of estimate your scale before you draw your x and your y axis. Okay, so I want to write in here the y axis, here the x axis. You want to plot that so that you have the you utilize your area, and then you can plot the exact point. You don't want it to be too tight. Okay, you don't want to be too tight. And then in this case, I know that I don't need to use the positive part of x, and I don't need to use the negative part of y. So I kind of eliminate this area to make it smaller, but I know that I have to utilize my negative part of x and my positive part of y on the third quadrant. So that's why I make this area wider so that I can see clearer and I can make a better scale on these two axes. Alright, thank you everyone.